Alright, now let's look at question 5, which is named, can I give you some feedback? So now we're given this slightly complicated circuit, and we know that VDD and VN are all connected to ideal voltage sources, which means they should be stable voltages. And we also know that G is a gain factor that describes this voltage-controlled current source. And we also know that the op-amp has some finite gain A, which means that Vx is going to be equal to A times V plus minus V minus. And we got this information from the fact that it has a finite gain. Okay, so given these information, now we have to figure out if Vout increases, what will happen to the following values. Okay, so let's establish a chain of events here. Vout will increase for the prompt's demand of experimentation. Okay, now let's observe the graph. If Vout increases, will the voltage at U1 increase? So we first have to figure out the relationship between Vout and U1. So let's assume that we have a current from Vout to U1 through this resistor, which I'll call IR2. And then we also have this current that's flowing to the positive terminal of the op-amp, which is I+. However, the golden rule tells me that regardless of how the feedback this op-amp is, the currents that flow into the terminals should be 0 amps. And Kirchhoff's current law is telling me that IR2 is equal to I+. Therefore, IR2 is equal to 0. And if IR2 is equal to 0, then that means there's no current flowing across the resistor, which means that Vout and U1 is actually equal because there's no voltage drop between them existing. So if Vout increases, then U1 will decrease, or U1 will increase because they're the same value. If U1 increases, then what happens is that V plus increases. If V plus increases, the value of V plus minus V minus increases, and thus Vx increases. Given that this op-amp gain should be a positive finite number, and Vx is equal to this gain times V plus minus V minus. So we know that Vx increases. Meanwhile, the voltage control current source ID is equal to negative GVx, and Vx is increasing, which means ID is decreasing because it's getting more negative, and G is a positive value. If ID is decreasing, since Vout is equal to ID times R1, which is equal to negative GVx R1, and ID is decreasing, then Vout should also be decreasing, and thus we are ending up with a negative feedback. And this is a negative feedback because by increasing Vout, we decreased V1. By increasing Vout, we decreased Vout, which means we have a negative feedback. Another way to test for negative feedback is that if we decrease Vout, we should see an increase in Vout instead, because the definition of negative feedback is such that if I tune the Vout in one direction, the overall circuit will work to have a change in the opposite direction for the output. So in this case, we increased Vout and then the Vout got decreased. So having grasped that concept for negative feedback, we have successfully solved the question.